Welcome everyone. Thank you for joining us for today's expert webinar titled Data Science What You Always Wanted to Know. I am Satyakshi from SpringPeople. We are India's largest enterprise training provider. I will be your moderator for today's session. In today's webinar, with over decades of insightful experience, we have our expert Kiran Babu, who has a unique blend of knowledge in data science, artificial intelligence, blockchain, machine learning, and SAP, to name a few. Kiran will introduce us to the world of data science, take us through the data science life cycle, and throw some light on popular data science tools and industry use cases. If you have any questions during the session, please type it in the chat box and they will be addressed by Kiran after the presentation is over. So without further ado, let's start today's session. Over to you, Kiran.
Hey, thanks, Satakshi, for that introduction. So, good evening, everyone. So, we will start this session with an brief introduction to data science. And as Satakshi said, we will go through the various vibes within the data science space. So, coming into the data science, the first and foremost challenge what we get to hear or happen to talk is understanding the various acronyms at a very high level. So we happen to use most of these acronyms very much overlapping the words artificial intelligence, data science, machine learning, programming. All these particular things are something which we use very much overlapping. Let's try to unbox what each one of them have to be in store and how they are related. If they are standalone, what is it in store for us to understand. Saying this, let's first go and understand what is artificial intelligence. So the word artificial intelligence predominantly is a combination of two things. One, intelligence, which is built artificially. So, before even defining what is artificial intelligence, let's try to understand what is intelligence. So, we happen to listen or hear, or we happen to even tell of the available animal kind, human being is the most intelligent mammal. Why do you call only human being as the most intelligent? The simple reason why we call human being as intelligence is the way he thinks, which is relevant for a given situation. So if at all I have to give a simple example, today when we happen to cross a road, when a road which a road which we often have to cross, that point of time, since we have been crossing that road for quite a few years, it does not make any sense for us to go and cross the road blindfolded, right? In sense, the scenarios which are available on the road are really runtime. It does not happen to say that since there was a white color car yesterday exactly at 9 a.m. crossing the road, today it does not have to be the same, which means as a human being you take a decision which is amicable for a given situation. You try to see, if it is a two-way road, you try to see on the both direction, you take that extra caution, you take the pulse wherever the zebra crossing is there, and whenever you happen to calculate that you can travel the distance to cover the road in the time what you have, then you go ahead and proceed to cross the road, which means that amicable thought of deciding when to cross, how to cross, where to cross is intelligence. In sense, if I ask anything and a cat or a dog, possibly they may not be able to do with the same precision what a human being can does. This quotient of bringing in an amicable decision for a given situation makes the humankind intelligent. Bringing that intelligence into a machine or an application becomes artificial intelligence. So basically, if we can try to delegate that activity of intelligence to a machine, we call it as artificial intelligence. So if I have to take an example of a car, in a car, all that we try to do is we try to make decisions. As a driver, we don't pull the car, we don't push the car. All that we are doing is sitting in the driver's seat, we are taking decisions. And as per one of the survey, it is said a human being takes anywhere between 121 to 125 decisions for every mile he drives. That's on an average. And probably this being in Western university, probably they have considered the global things. In an developing countries like India or any other developing countries, the number of decisions might be even more higher. Which means all that we are trying to do is we are sitting in the car and implying or applying the decisions on the car, when to start, when to move, when to apply brake, when to go fast, when to go slow. If we can delegate that activity of decision making to a machine so that it responds to the change in the environment significantly, which is according to the need, then a car can be called as an intelligent car. Today we have an automatic car, but we don't have an intelligent car. The self-driving cars, what we have been talking about, is the approach to bring that particular thing, which means we are delegating the decision making quotient into an artificial instrument or a vehicle in this case. This way, the activity is more of delegating what human being has been doing. If at all we have to see what we have been already experiencing to see about artificial intelligence, the simple example is the cameras on the mobile phones. Of late, you get to see so many phones are getting enabled with AI enabled cameras. So what is the action of a camera? To take a picture. The subjective quotient is to take a perfect picture. And what is perfect? Each one of us define differently. For me, a picture with bright color might be perfect. For somebody else, a picture with zoom in might be perfect. For one other, a picture with zoom out can be perfect. Once we start using the camera, the application gets to know and understand our taste, and whatever the decision we were making, like if I have to get bright light, I have to switch on the flashlight, or I have to change the aperture, somebody has to change the zoom, which means the technical parameters is a decision making skill which I was doing previously to take a photo or a perfect photo. Now that act of making the technical changes has been delegated so that the machine becomes intelligent enough to adapt to the right parameters and click a picture which is a perfect picture or a photo. That way, artificial intelligence plays a role in terms of making amicable decisions. So, if this is artificial intelligence, then what is data science? Very simple. So, data science is similar to artificial intelligence, a combination of two words. And if we have to define what is science, anything which is repeatable, replicable, logical is science, which means as long as we can make things which is repeatable, replicable, and logical. So if I have to put an example of 2 plus 2 is equal to 4, 2 plus 2 is equal to 4 anywhere in the world, which is repeatable. And if I have to say 2 plus 2 is equal to 4, it is replicable. N number of times you try to add, it cannot become 3.9 or 4.1. It is replicable. And it is logical. Every one of us can prove 2 plus 2 is equal to 4 in 100 different ways. So, this activity of finding a pattern within the data, which is repeatable, replicable, and logical, becomes data science. So the reason I say it's an art, because each one of us look at data differently, and data has so many vibes to present us. But identifying any pattern which is repeatable, replicable, and logical becomes data science. Let me pick an example here. This was one of the data science experiments done by one of the eminent retailers in the United States. So, what they did was predominantly they are one of the or they are the biggest retailer in the world, Walmart, as all of us know. So they were collecting their sales data over a significant amount of time, and to give the weightage of number of transactions what they do every minute, Walmart makes more than 1 million transactions, sales transaction every minute in the United States. So with so much of quantum of data available with them, so they wanted to see if they can find anything meaningful from the data what they have collected, and they started using all the statistical and data science approaches, and they found an interesting pattern which the data science was resulting them into. So what it resulted in is, over the weekends in the United States, Friday, Saturday, and Sunday, the 3 days is considered weekends. For that matter, in India, most of the cities follow the same. So what was being observed is, all over the weekends, the number of people buying diapers, the kids diapers, with beer cans were significantly higher. Now humanly it is very very difficult to accept somebody buying an adult product and a kids product together, both different category products. But the data was saying that. Then they wanted to test whether whatever the findings, a pattern which they found, is really right or wrong. What they did is, they started co-locating both the products. And many of us know, or whoever have not visited Walmart, usually Walmarts are 3 to 4 times bigger than the mega malls what we have in India. So usually they are 1 to 4 lakh square feet. So with such a large land space, usually they are wide apart, and it's a 2 3 minute walk from a liquor section into the kids section or vice versa. So all they did was, they co-located these two products to see if whatever they found it scientifically from a data science perspective, was it really right or wrong. And to their surprise, over a period of time, what they observed is, the sales increased 7 to 11%. 7 to 11% increase for a retail segment or a retail store, where they have not sourced any new product, no advertising, no marketing, is really a significant achievement. This way, they were able to identify what can be sold together and what does not get sold together. So just because a beer and a diaper were getting sold, you cannot tag a shoe polish and a carrot tomorrow, right? It becomes an haphazard store. But with 60,000 products, more than 1,000 people visiting them every day, every single store, identifying such interesting patterns and trying to materialize a value, a enterprise value on that particular thing, without disturbing the predominant enterprise structure, becomes data science. There are so many such insights which many industries are able to find. And for that matter, even in India, there was a very interesting fact of the 1 second pulse which was generated in the telecom company, which was a result of data science. In sense, the moment they identified the number of people where the number of calls which were short spoken were too high in comparison to the long calls, that's where they observed this pattern and wanted to introduce a different pricing with the pulse price per second rather than per minute. So this kind of trying to find some meaningful insights from the data which is not collected for that purpose, becomes data science. So if this is data science, then what is machine learning? So basically, we did see what is artificial intelligence, what is data science, then comes to our section, what is machine learning. As the name suggests, again, by this time, if you are coherent and you are seeing the way we were approaching things, we will try to define what is learning and then we will try to define what is machine learning. So, when we have to just go and define what is learning, one of the definitions what you can tell for learning is an activity of converting data into knowledge. So if you happen to remember, walk back your memory line, most of us would have done a learning activity. For that matter, even this session is a learning. Or if you remember the way you did learn your bicycling, the first 3-4 days of your experience of learning a bicycle was to just sit on the bicycle. Someone were helping you, it can be your parent or somebody, or the additional wheels, but you were consuming the data, which means you are trying to understand how to sit on a bicycle, how much pressure to apply on the pedals, how to hold the handle, how much inclination I have to make if I have to make a right turn or a left turn. All these things were the data collections which were happening the first 2, 3, 4 or 10 days based on individuals consumption. Once you were able to consume all of them in the right recipe, you started claiming that I know cycling, which means from the day 1 to day 10, nothing changed, nor the cycle, nor the location, nor the person. The only claim what it got changed from day 1, where you said, I don't know cycling, to the claim, I know cycling, which means the data what you collected got converted into knowledge so that you can reuse. The activity of making such an effort on the available data by a machine to make it learn on some data set and help it to take a decision on the new data set becomes machine learning. In that example of cycling, today, even after 10-15 years or 20 years, if you are given with a new cycle, a new location, you don't have any problem, you are able to cycle, which means for a new kind of data with the previous knowledge, you are able to execute things. Making machines capable of doing such things is your machine learning. So, in nutshell, what you happen to do is converting data into knowledge. So, we defined most of the things, which means if we tried to speak about what was artificial intelligence, what was data science, what was machine learning. Now, how do we achieve all of this? For that, we need to have something at the end, which is the technology stack, which can apply the logic required on the data before it can be used. So for that purpose, you happen to use your programming. So for this transformational space, the reason I call data science as transformational is there every industry today, whichever is doing business, generates data, and whichever industry is generating data will have some or the other key takeaway from data science. They cannot get shielded themselves saying that I will not use data science. So from that perspective, it is transformational in nature. And to do the transformation, you can use any programming language like Python, Java, R, C, C++. But given the fact it is data intensive, Python and R are the most preferred programming languages for this setup. So that way the programming, the machine learning, data science and artificial intelligence are interrelated. So if we happen to see this diagram, the reason I have brought this diagram is our brain very well accepts anything when it is correlated with something which we know the most. So if we have to see this particular thing, at the outset it is a logo of Audi, right? The Audi car, which means the reason why I bought this particular thing is the artificial intelligence, the machine learning, the data science, and the programming are interrelated, which are overlapping in nature. There is something which is connected, and for all of this, the common agent which needs to be provided definitely is data. That way data becomes the pedigree or the raw material, and at various stages you happen to say various things. So with regard to the programming, as we said, we can use Python, we can use R, we can use Java, or any other programming languages. That gives us some background on the vibes, how exactly we can relate the whole approach, and what each one of them, what is the scope. With that, we will have to see what is data science, right? The need for data science versus business intelligence. Let's try to see that particular aspect. So data science, as I said, predominantly is about some pattern finding. So if you happen to see with regard to the airline industry, if we have to see and talk about it, every Boeing 337 generates roughly around 25 terabytes of data for every 8 hour of travel. Now imagine a flight between Bangalore and New Jersey, which is around 18 to 20 hours. If it is a direct flight, it generates almost 50 terabytes of data. But trying to find some insights from that becomes very, very meaningful. So you use data science for various aspects in airline industry, and for that matter, at any given point of time, there are more than 14,000 aeroplanes in air. Before the pandemic, that was the numbers. Probably now that is not the real numbers. The numbers have significantly changed, but with so much of air traffic being available, it becomes significantly difficult to do your time management, route management, and new route planning. For all these particular things, we will have to leverage on a procedure which can be of industry standard, industry grade, which is what data science provides us. So with that particular thing, what all we can do with regard to data science in an airline industry: predictive analytics to model and foresee the flight delays, route planning, promotional offers for ticketing, or deciding which class of planes to purchase for a better performance, are all some small key takeaways from the data what it is generated. And recently I even saw an article saying that since the number of aeroplanes are drastically reduced, the weather prediction is going for a toss. The reason is 30% of the data for your weather predictions were getting generated by the flights which were flying at the high altitude, which means they were also being used as the input leaders or the data generators for your weather prediction. With the number of flights getting significantly reduced, the data science approaches are becoming more and more fluid. Next is for the logistics. So we know, for example, if you have to take the example of India, around 83% of the Indian internal movement happens on road. Goods movement and passenger movement happens on road, which means it can tell me how much of strain and stress is available with regard to your transportation. So to beat that particular thing, the logistics companies, like the big companies like the FedEx or DHL, use data science models to bring in more operational efficiency. And for that matter, the aggregators like the modern age aggregators like your Swiggy, Zomato, who are able to promise a delivery in 15 minutes, 20 minutes, or half an hour, are leveraging data science optimally to make things more and more repeatable, more and more customer acceptable. For that reason, data science becomes a very, very important fact. Need for data science the mainly answers these three questions: better decision making, predictive analysis, and pattern discovery. Like I said, a decision is all about choosing from the given options. I always try to pick this example. A decision is like choosing what to eat at a buffet. You have everything rosy, everything very good, everything done by best of the chefs. But in spite of that, if the spread is 40 items, 50 items, 30 items, you probably cannot consume everything. The 5 items or 10 items what you can consume is a decision what you made in accordance to the overall items which were available. So is it A, B, C, or whatever the extension? Predictive analytics predominantly, like we saw in the weather or the delays, how exactly you can bank upon based on the information what you already have. So if you happen to see some of the predictions what were done by the weather department of late were to a very great accuracy. We saw recently the two cyclones which were supposed to, or rather which hit India on the east and west side, were accurately tracked and minimal life and property loss. Property loss is something which you cannot avoid to a great extent, but life loss was handled spectacularly well because of the right data which was available to them over a period of time, which is again a result of predictive analysis. Pattern discovery, like we have been talking, lot of patterns to are available. It is only for us to see and choose how we can identify these patterns. That gives us the whole crux, saying what exactly plays a vital role for data science. So where is data science used? Various placeholders. Probably we don't know, we are being a part of the bigger picture of data science without our understanding, right? So recommend the right product for the right user is a part of data science. So probably if you happen to have to buy an air conditioner or a television or any other electronic gadget today on any of the e-commerce website, they try to help you to go through a simple questionnaire before the machine suggesting you what is right for your need, which again can be today, it can be a combination of your question and answers per se, but the recommendation systems are becoming more and more intelligent. So the other day I was trying to pick up a remote, and suddenly the e-commerce store popped up saying that for the TV what you have, this remote is incompatible. For the simple reason, the TV was also bought on the same e-commerce website. So it did try to identify the remote what I was checking for the TV is not something which is compatible with the TV what I have, which is recommending a right product for the right customer. Right? So that way you become to use data science. Then you can use it for predicting the characteristics of high value customers, mid value customers, building intelligence ability in the machines, fraud prediction. Very, very needed thing for the our cyber security is all about it. And for example, banks and insurance companies are using the fraud predict fraud detection very, very exclusively. For that matter, even if you happen to see your Gmail, if you happen to log in with your Gmail ID in a new computer or a new laptop or a new phone, the first time it will ask, or rather it will send an OTP or a message to your phone number which is linked, to avoid fraudulent. In sense, it has a track of which are the regular systems which you are using, and whenever it happens to see a new MAC ID or a new IP address, it wants to avoid any fraudulent. In addition to this, sentiment analysis predominantly is again a key takeaway of data science, which predominantly is about to understand how customers react for a given event. Accordingly, the strategies can be mapped and planned. So, saying this, these are some of the few key takeaways how you can use your data science. Then trying to go to the next level of the data science, the biggest enabler for the data science becomes your input, which is in various shapes and forms. It can be in a structured data, unstructured data, social media data, or multimedia data. So the big data plays a significant role in feeding the approach for you to determine the right pattern or predictive analysis or anything. So basically, extraction of knowledge from the large volumes of data that are structured or unstructured becomes the crux of data science. And to get you a vibe, the amount of data what is getting created in the world every day runs into few millions of terabytes, or rather 2 to 3 yottabytes. And to give a vibe, every second tweeter gets around 6,000 tweets. Every minute there is more than 1.4 million searches on Google. With so much of data getting generated, data science has a significant amount of pedigree for it to extract knowledge from this large volume. So it is continuation of the fields of data mining and predictive analytics. So if we say, is data science something new? The answer is no. Data science existed for a lot of time, but today we have been able to add the technology to it to improve the processing and predictability quotient of it. Probably when we were doing it previously manually, the amount of time which required for us to process such large data was significantly high. Today, that hardship has been delegated to the machine or the technology, and it is able to process data to the tune of multiple terabytes within few seconds. That way, data science relevance with regard to wide data and big data is becoming very, very relevant. So that is the whole scope of data science. If you have to see how exactly the data science gets around, it is this is a simple life cycle process. We have a much curated life cycle process, which we will see in the later slides. But at a very, very high level, you get the raw data, you happen to clean up the data, and during the cleaning up of the data, you happen to go and do EDA, which is explore the data with regard to basic statistics, visualization, cleaning up in terms of outliers, missing data, which we call as data treatments. And then we apply that to on a model where we say feature engineering. Then we make the model learn through the data, and then test it, validate it, and then get to the final go, which is your final product. So if you happen to see, the two areas which we require is the domain knowledge, which is very much business centric, and expert knowledge, which is more technology centric. So basically, if you have a data from a telecom company, until and unless you don't know some of the technical vibes, you will not be able to treat the data very well. So for example, if I say the pulse, or if I say the ARP or AURP, which means they are very, very close, very, very technical from a telecom perspective. At the same time, if I have to take a retail, I say SKU. So this kind, you will have to be able to understand that way the domain knowledge plays a significant role in terms of processing the data, and in terms of the final output, the expert knowledge from the technology end plays a vital role. So how do we do this? Basically, we will, if you have to see this, Basically, this is an example of the traffic feed. So there are multiple feeds for some instrument to help you to understand the traffic. So it can be data as tweets, extract time, location, traffic level using the natural language processing. Then you explore the data, model based on the time and its holiday, and predict the traffic given at a given location. For that matter, I don't know, many of you might know this or may not know this. Google Maps, which we use more often than ever for our location, or knowing a given location and knowing the given traffic, does all these particular things. Predominantly it uses our mobile instrument itself as the data sourcing. So at any given point of time from a given location, it tries to capture how many given parallel phones are available on a given junction or a given road, and then it tries to remanipulate and revisualize the data and present it back to us, saying that whether the traffic ahead is clear, or is it amber, which says that the traffic is piling up, or is it red, which says that the traffic is extensive. So this is an activity of a data science. It is doing the data collection, runtime it is doing the data cleanup, runtime it is doing the visualization, runtime it is presenting the output. That way it becomes a significant fact. Coming to the data cleanup, as per some of the eminent machine learning and data science companies like IBM, Google, Microsoft, it is said around 70 to 75% of the time in a data science project goes to the two steps, which is data collection and data cleanup, of which significant amount is for your data cleanup. The reason is the data is in all shapes and forms. There is nothing called as good data or bad data. It is all about relevant or irrelevant data. So I always keep telling, there is no question of discarding the data. The situation is all about discounting the data for a given goal. So with that particular things, you will have to treat the data for various shapes and conditions, like bad data, missing data, useless variables, wrong data, all these particular things. There is a way to deal, and there is no one standard principle saying that first you have to do a bad format thing, then you have to do missing. That's not the thing. But based on the goal, based on the situation, based on the requirement, you will have to take a runtime approach in terms of data cleanup. Then the same thing, where once you do that particular things, you will have to do the data transformation. What happens in data transformation? It is about right engineering. So always we might end up doing over engineering or under engineering, but doing right engineering is what the data science requires. So for that, you will have to do the transform variables, which means changing the types of formats, trying to get derived values, trying to see how you can try to read some meaningful patterns, normalize the things, feature value rescaling, enriching the data. All the things are some of the sub steps which are included as part of your data cleanup. With this, you will go ahead to the next stage of data exploration. So what happens in data exploration? Predominantly, you will try to check how exactly the data is meeting up the given requirement. Many a times, just after data exploration or before data exploration, at both times you do the data visualization to see the pulse of the data, what is there. So you also use some of the statistical approaches, like the mean the mean, medians, or some of the other statistical approaches of using some algorithms. All these things are done at this stage as needed. So here, like I said, probably the visualization, which is plotting of the graph, which can give you a lot more insights than seeing the data as tabular in nature. So with the English statement saying a picture is worth more than 10 words, the same thing applies here. A visualization can talk more than a million records. That way you try to plot the data, look at the data to see if there are any dependencies, then you go ahead and plan your further activity. So this is predominantly an example of data exploration to see how the data is plotted. You try to visualize the data both on a two-dimensionality or three-dimensionality or multi-dimensionality in terms of taking a right approach and a right decision. So in some cases, we might have to talk about feature engineering. So what is feature engineering? Feature engineering is the art of finding the features that leads to the simplest decision algorithm. So as we say, the human brain is one of the best God made devices, right? So what happens here, for example, each one of us write the alphabets or the numbers in a different fashion, but our brain is able to recognize each one of them, whether it is 1 2 3 or A or B, and we are able to read the content. Making a machine to identify such things goes on identifying such features and combining those features in a pattern which can bring in some meaningful insights. The activity of doing that is your feature engineering. So this is in nutshell how exactly what exactly we do a part of your feature engineering. So basically we pick up some manual domain experts, search for possible features, the training constraints. We use sort of the approaches like your principal component analysis or PCA, and then we also use some of the deep learning techniques which are available as part of your deep learning processes to extract some unique features and get going. That is your feature engineering. So the final output is the goal, right? The analysis. In our example of Walmart, the goal was to see what can be found which can be co-located together. So once you have such things, you will have to do your analysis which meet the ends, and that way the analysis are enterprise beneficial. That leaves us to a section where we will try to talk how different is data science. Somebody can ask me, we were doing all these things in something called as business intelligence. Yes, we were doing it in business intelligence, but the key difference between what we did as part of business intelligence versus data science was business intelligence had a scope of very limited to structured data. It has a challenge in terms of consuming unstructured data or semi-structured data or multimedia data, which data science can overcome. So here the approach what we use is just statistics and visualization. But in addition to statistics and visualization, we go a further step of using the natural language processing, neuro linguistic programming, and machine learning for us to get an higher accuracy. So the business intelligence or the BI systems were predominantly concentrating on past and present, but here it is getting extended to the future. And the tools what we try to use in business intelligence predominantly are your BI tools, SAP BI, Microsoft BI, Pentaho, QlickView. All of these are some of the tools what we use as part of our business intelligence, while as part of our data science we use various tools such as Python, RapidMiner, Big Machine Learning, Weka, or some of the cloud-based tools, even Azure and AWS also have the tools enabled for you to consume large data sets and bring in some meaningful insights. That gets us to a refined level of your data science life cycle. So if you see this, this is your refined data science life cycle: the data discovery, data preparation, mathematical models, getting things into action, finally making the application consumer or customer facing. So Data discovery and data preparation, like I said, take a significant amount of time in any given data project or a data science project. Once you have that, you happen to use some of the mathematical models and the statistical models, then you use the technical acronyms like a machine learning or a deep learning approaches, and finally you validate that and then make the system live. So in nutshell, this is what you get to see as a simple life cycle of data science. So what we happen to see, the components associated with data science: programming, data, statistics, machine learning, big data, and development tools. So data in various types, we've been talking structured, unstructured, semi-structured, multimedia data. All of this is the data. Programming, like it enables you to use either Python or R, for the simple reason both of these programming languages are computational rich programming languages. Then you happen to go and use your statistics and probability for you to make things happen. Then that way comes us to the scope where we will see how exactly data science is being used in the industry perspective. So if you see, I have tried to bring up all the different industry verticals which use data science. Right. So basically, the if you happen to take the travel, which which is an industry which is most affected in the pandemic, but if you happen to see previously, the flight pricing or the hotel pricing, which was dynamic in nature, was leveraging, or rather is leveraging, data science to the core, which means it can bubble up the real time demand supply requirements and then put a price to that particular thing. The second thing, predicting the flight delay. So I was giving you some numbers here. So if you happen to see how many aeroplanes will be there in the air at any given point of time, previously the number was 21,000 aeroplanes used to be in air at any given point of time before the pandemic, which tells us how much complex the air industry is, or the aviation industry is. So if you happen to see, predicting the flight delay is the most complex thing. And to do that particular thing, you have to leverage data of multiple magnitude. Then coming to your marketing. So predominantly in marketing, whatever we are seeing is the upselling and cross-selling. So if I have to just give a brief thing about upselling and cross-selling. So if you happen to buy a mobile phone, and you are encouraged to buy an additional protection guard, or a mobile phone cover, or an extra battery, that is your cross selling. And if you had happened to plan to buy an iPhone 8, and the person who was helping you to buy the product was able to convince you to buy an iPhone XR, then it is upskilling or upselling. Not upskilling, it's upselling, which means within the same product category, you are able to provide additional benefits to the customer and make him buy. So if you happen to see in the retail segment, especially in the e-commerce websites, many a times you see the recommendations down below saying that these are the products which others have also bought. It is your cross selling. And as per Amazon's own website, more than 30% of their revenue is generated by cross selling, which means a customer comes to a site to buy one product, they're able to sell 1.3% or 1.3 products. That gives them the additional leverage. And coming to your next section on social media, sentiment analysis and digital marketing, both of them is used to target the right customers or the right audience for given products. So how do you identify who are the right people or the right audience? Is the activity which data science performs. So many a times you would have also seen, if you had searched for a mobile phone, the ads which come on your browsers are very relevant to that mobile phone. which means they have identified you as a potential customer, and that's the reason why the digital marketing promotion is very specifically targeted for a mobile phone. So that becomes your digital marketing and sentiment analysis. Then comes to automation. We have been talking about automation. So self-driving cars, pilotless aircrafts or drones predominantly, which can enable them to make runtime decisions on the go, is one of the very clear and clean key takeaway for an automotive industry with regard to data science. Then the healthcare. So probably today, with the pandemic around, we are seeing so much of leverage with regard to the technology. So it can be in predicting, visualizing. So if you happen to go to the Microsoft website, which projects or which displays the daily stats, there is so much of visualization available on their website with regard to what is happening with regard to COVID across geographies. This is again for the healthcare. And if you happen to see from the medication effectiveness for the pharma companies, this is also the same, where they happen to replicate various models and see how exactly you can do the things. So that way, if you go ahead and see, this is the Microsoft Bing product, which gives us the insights of what is happening. And if you happen to go here and see the graphs, it gives you a holistic picture for a given geography, how exactly the spread is happening. That's how many people try to do some analysis on the raw data and try to see. So this you can do it at the global level or a country level or a state level, however it has happened to do. Then we know, when we saw marketing follows sales. So basically the discount offering and demand forecasting, which is very important subject with regard to uh, marketing, sorry, with regard to sales, can be leveraged, or rather data science can be leveraged here to do right things. And last but not the least is on credit and insurance. So predominantly finance and insurance industries are one of the industry which has a significant adoption of data science, because they have significantly higher data and they have been already using. So this will help them to calculate their premiums, they calculate their frauds or claims prediction. All these particular things can be done using the data and applying the right data science techniques. Okay, so this way you get to see how the industry is using it. So if you see this, this gives you a simple thing saying that in India, Mumbai has the highest number of COVID-19 cases, followed by Chennai, or followed by Ahmedabad has around 19,000, while Chennai has around 47,000. This gives you a visualization rich in one outset what is happening across, right? So this gets us to a place where we did cover, or rather discuss about all the factors and things which we had planned. So with this, let me hand it over to Satyakshi. Satyakshi, do you want to talk about our offerings in terms of data science?
Yeah. Thank you, Kiran, for your invaluable insights on data science. I'm sure it was certainly a very beneficial session for all of you. If you guys are interested in learning more about data science or other technologies, do check out our batches of VILT trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable batches, we would be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses, especially for data science. It's 2,995 only. For more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Now, we will open the forum for Kiran to answer the questions that we have received during the PPT. Over to you, Kiran.
Okay, so let me go ahead. I will be more than happy Okay. So any questions or anything, guys? I see one question. How to start a data science as a career option with having a programming knowledge? Okay, so data science, as I said, it is transformational, and you having a programming knowledge definitely would have worked on a given business vertical. So learning any of the data science technology stack is the first step, like learning Python or R programming becomes your first step, and then you will have to learn the strategies associated with data science, and then you can go into the thought leadership. That way it becomes a seamless career transition. Okay, what are the job opportunities related to the business analyst? How do we start a career in this area? So the job opportunities are ample. As I said, there is no industry vertical which can get shielded itself saying that they will not have data science to be part of their IT landscape. So as a business analyst, predominantly you handle the data sources, data visualization, data processing. That way it becomes a win-win situation in terms of switching over into any of the machine learning and data science projects. Okay, I want to ask, data to learn, okay, data science, do we need to learn machine learning and AI? Not necessarily. So this, as I said in the initial section, these are three different verticals. Data science is all about processing the data, trying to find patterns, enabling the machines to make the self decisions is your machine learning. Encapsulating both of them with programming becomes your artificial intelligence. That way, in a whole data science project or a machine learning project, you will have all the components, but not necessarily all of them should know all the three. Hope that answered your question. Okay, how data science is different from machine learning? Smita just answered that. Predominantly machine learning is the activity of making machines take decision, while the activity of finding data, treating data, and finding patterns is the scope of data science. Okay, how many levels of mathematics knowledge is required? To be very specific, for data science and machine learning, rather than mathematics, statistics knowledge is more required. But if you happen to learn and work on deep learning techniques, you will have to have an understanding of linear algebra, which usually is taught again as part of your deep learning curriculum. Okay, being a data science engineer, Hadoop is the backbone for processing huge data. Okay, being what is the scope of creation of data warehouse? So like you said, a data warehouse is restricted with the data. You can take the data warehouse to a limited level, but if you have to blow up beyond certain points, where I say Facebook generates 500 TB of data every day, imagine how much of data it is generating every year. Where a data warehouse cannot handle such things, there you will have to look for some better opportunities than a simple data warehouse. Okay, so what is the input for the people who wants to use a simple use in simple project management or organization for an interpurpose? Okay, so there basically, if you happen to see, the machine learning and data science is uh, about the way you can treat the data and you can meet the data. That way, for your project management, there are tools which are able to do various levels of your project scheduling by itself. In sense, it reads the data, understands, make the decisions, get going on the right time. So there are so many internal tools which are available for in the market using data science, which needs the data as the raw material, and the downstream activities are can be achieved by them. Okay, so what is the package offered for an invoice for a novice data scientist? Ranjan, it depends on the geography. In India, the data scientist salaries range anywhere between 12 to 60 lakhs per annum, and in the United States, the salaries ranges starts 1.2 lakh US dollars and above. Okay, so if we are new or fresher to data science, then will it be difficult for us to learn? No, being in an a learning curve, it would be much easier for you to understand and adapt the concepts and get a seamless transition into the stream of artificial intelligence and data science. What level of programming knowledge is required to learn machine learning? So probably I would say on a scale of 10 you should be around 5 to 7 for you to be comfortable in doing machine learning algorithms, because most of it today is library driven. So the programming quotient is coming down, but understanding the business and adapting the right libraries and right functions is the ask of the day. Which one is the best, Python or R to learn data science? So both Python and R have their own pros and cons. So Python is widely adapted. It has a very strong community, and it is easily learnable. And the advantages of R are it has some of the deep libraries for your some of the statistical rich requirements. And in comparison to Python, the user community is on a lower side, but still there are various programs which leverage R as well. Okay, so which companies are offering career opportunities for data science at the current situation, Samira? Probably there is no one a company with more than 300 or 400 people which are saying there is no opportunity for data scientist. So every company in last 2 years have relatively more than 4 to 8% of their workforce who are working on this digital acronym. And what is getting projected is year on year growth is more than 50%. So that tells you how many openings or opportunities are figured out. And as per the latest survey, more than 150,000 open positions across the levels are available in India. Changing technology from data science, will it be treated as a fresher? Definitely not, Avinash. So basically whatever the industry vertical you are working, you should be strong enough, and you can adapt the data science and machine learning leverage onto that, and then get your start from that level. It is not about that after 5 years or 7 years of experience you go ahead and start as a programmer, right? That's why I said there are various levels in the data science, and there is a mapping which happens based on your experience, based on your strategies, and based on your level. That way the mapping definitely makes a relevant thing. Would there be a duration for this learning? Probably there are various things. If you are doing only Python, only data science, or you are doing an exhaustive course, that will decide the timeline on how much time it takes. Can we switch, as it we have nil knowledge and experience it? Mohit, yes, predominantly it is not that you don't have knowledge, but it is about how we can leverage your knowledge for this transformational technology is all that matters. So being a working professional or being a graduate, you already carry a lot of knowledge, and now it is transforming that knowledge into enterprisal value. That way it really makes a sense. And somebody, I will take the last question. So basically, is there a way a person from testing background learn data science? Definitely yes. If you say testing, it is all about finding, or rather I trying to understand how good or how deviated is the product from what is planned, and machine learning is an extension to that. That is, there is a deviation or there is a no deviation in terms of decision making. So you are extending your things if you are already doing testing, or rather in a sense you have already started your data science and machine learning journey. Okay, so that was the thing. Thanks for all the questions. If at all you happen to have any questions, you can write us to the email address what you see on the slide, and we will try to help you out. And you can always sign up for the curriculum which is available on the springpeople.com and get going. So that leaves us, Satyakshi, you can go ahead.
Yeah. Yeah. Thank you, Kiran. Thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants by Monday end of the day. I request you to kindly provide feedback before signing off, which will help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Bye bye. Stay alert, stay safe, and healthy.